Hello everyone, welcome back. So we're going to start our second set of videos for the Chem 1W course, and we're going to be doing Chapter 2. As you can see here, we're going to be talking about measurement and making measurements and unit conversions. This is perhaps the most important chapter for the Chem 1W course because all of the concepts that we learn here you're going to use repeatedly throughout Chem 1. So when you go into the Chem 1 course sequence, you're going to be using these techniques and approaches to solving problems over and over again. So hopefully you can learn these concepts now. So what I first wanted to do was talk about, in general, why do we care about making measurements? So of course we talked about a little bit of an introduction to matter in Chapter 1, and at the end of that we talked about the scientific method, scientific inquiry. So of course, as a chemist, as a scientist, you have to be able to collect data, you have to be able to make measurements in order to carry out scientific inquiry. So that's one of the most important reasons. We also need to be able to manipulate measurements in order to interpret them. So once we've collected data, you'll often have to manipulate that data in certain ways or modify it perhaps, express it in a different way. In order to work with it. So it's very important that you can be able to work with these different measurements, different units. So in chemistry, we need to think about, well, what are the specific types of things we're going to be measuring as a chemist? So I'm not going to be covering every type of measurement that you might make as a scientist, but I'm focusing on specific things that we deal with in chemistry. So we have first what we call fundamental units. And so fundamental units are essentially things that we can measure that kind of represent a fundamental property. So for instance, if we're looking at the size of something, we may express it as a distance. So meters would be a unit that's fundamental in expressing distance. The mass is something that we often will measure in chemistry, and it's a fundamental unit that describes how much matter is present. A couple of other units that we will deal with frequently are time. So when we deal with types of reactions, we'll look at the speed of reactions. So time is a unit that we'll often measure. And then, of course, temperatures is a critical unit or measurement that we'll be making frequently in chemistry. So when we talk about heat changes, we'll often measure heat changes as a change in temperature. So these are very, very important. So in addition to these fundamental units, we will also have what we call derived units. So this is a measurement that we would make in which we've combined in some way some combination of these fundamental units. And so in chemistry, volume is a very common derived unit that we'll deal with. So looking at the volume of a liquid that we might be dealing with, the volume of a gas that we might be working with in a lab. And so volume is a combination of the distance fundamental units. We're taking distance times distance times distance. So here we have centimeters cubed as an example, which we will also call liters. So that's a very common derived unit. Density is another derived unit that we'll deal with quite often in chemistry. So now we're combining mass with volume. So we have the fundamental unit mass combined with the derived unit volume. And then energy is another critical unit that we'll deal with frequently. So this one's a little more complicated. So here you can see we have mass and distance and time. So kilogram times meter squared per second squared. That's what we call the joule. That's a very common energy unit. So we'll introduce this a little bit later on in Chem 1W, but you'll cover that in a lot more detail in Chem 1A and Chem 1B when you get to those courses. All right, so what we want to do now is we want to think about when we make a measurement, how are we going to express that measurement as a number? And so the example that I want to give you is when we think about measuring the volume of a liquid using a graduated cylinder. So this is a device you'll use in lab when you take the Gen Chem lab. It's called a graduated cylinder. And I'm just going to give you a very crude example first to show how this works. So I'm going to draw a very crude beaker. So I'll draw this, and let's just pretend that we have 2 marks to measure, one that can measure 1 milliliter, and one that can measure 2. And let's say we have water, and we're just going to pretend that we have water in this beaker up to that level. And so what we want to do is, how could we report the volume of this? So if we want to measure the volume of this sample of water. So we would measure to the bottom of the level, of the water level in that device. And so what we now have to decide is, well, what's the number that we report? So we can see hopefully pretty clearly that this volume is definitely above 1 milliliter and it's below 2. So we can report with certainty that we're at least at 1 milliliter. But now, based on the marks, the graduations on this device, we can also guess a second digit. So it looks like it's maybe slightly above halfway between 1 and 2. So we can say, well, this will then be 1.6 milliliters. And so what's important about this is that the device we used here is dictating how many digits that we report in our measurement. And so I'm going to call this the estimated digit. And even though we estimated that last digit, this measurement has 2 significant digits. Okay, so the significant digits, they're telling us how many numbers, how many digits are we actually able to measure using our device, whatever the measurement device may be. And so when we start talking more about significant digits, we'll often, of course, in the class, we'll be dealing with measurements that have kind of been created. You're told various measurements in the book. But as you encounter these, try and appreciate that these measurements come from something, some instrument, some device that actually gave us this number. And so a lot of times when students are taking a course, they get kind of frustrated with significant digits. They seem perhaps tedious at times. But try and remember, this is important. It is kind of giving us an accurate reflection of what does this measurement device tell us. All right, so what I want to do now is give you a practice question. So here you can see this question. You're now using a graduated cylinder that's a little more sophisticated. It's got more marks, as you can hopefully see there. So what I want you to do is pause the video and take a few moments to answer this question and see if you can report that measurement to the correct number of significant digits. And when you're done with that, you can restart the video and we'll discuss.